This is practice problem 7.5. Eye cataracts are responsible for over 40% of blindness around the world. Can drinking tea regularly slow the growth of cataracts? We can't experiment on people, so we use rats as subjects. Researchers injected 14 young rats with a substance that causes cataracts. Half of the rats also received tea extract. The other half got a placebo. The response variable was the growth of cataracts over the next 6 weeks. And the researchers found that the tea extract did slow cataract growth in the rats. For part A, we want to outline the design of this experiment, and you can follow the example of the chart on page 253 of your textbook. So we start out with 14 rats available for the experiment, and then we randomly assign them to 2 groups. So we're going to have 7 rats in the first group and 7 rats in the second group. The first group will get treatment 1, which is the tea extract. The second group will get treatment 2, which is a placebo treatment. And then after 6 weeks, we're going to look at these and compare the groups of rats. And we're going to look for cataract growth. So that is an outline of the design for this experiment. We've got 14 rats. We split them into 2 random groups, 7 in each group. The first group gets a tea extract treatment. The second group gets a placebo treatment. And then after 6 weeks, we compare the cataract growth in the groups of rats. For part B, I want to use table 7.1 and starting at line 108, assign rats to treatments. So you'll have to use 5 lines of the table to get 7 eligible labels, and I've copied those 5 lines here on the slide. So reading off the table, first I want to get successive 2-digit groups instead of the 5-digit groups that the table is split into, and that will give me all of these 2-digit labels. That's just reading across and down the table. Now once I've got my labels, I need to cross out first all the labels that are not in my range. So say I label my rats. There's 14 of them, so I'm going to label them 0, 1 to 14. And I want to cross out any labels that don't fall into that range. So I'll go ahead and do that. So these first 2 don't fall into that range. 7 is good, it is in that range. And then everything up to here is not in that range. 0, 9 and 0, 6 are in there. The rest of these on this row are not. 83, 36, 0, 0 is not. I get all the way up. Looks like nothing in this row is in my range of labels. Let's look at the next row. I'll cross out everything that's not in my range. And here I get up to here, and 0, 6 is in my range, so I'm not going to cross that one out. Cross out these 2. And then these 2, 0, 8 is in my range, so I don't cross that one out. And I keep going. The next one that I see that is in my range is this 12, so I don't cross that out. I cross out those two. Just keep looking for things that are between 0, 1, and 14 here. I've got 2 0, 4s in a row, so I'll keep both of them for now. And then 11 is also in my range. And looks like none of the rest of these are, so I can cross them all out. So let's write down what I've got left here. I've got 0, 7, 0, 9, 0, 6, and then I've got another 0, 6, 0, 8, 12, and then 2 0, 4s, and 11. So now I need to cross out duplicates. I've got 2 0, 6s, so I cross out the second 0, 6, and 2 0, 4s, so I cross out the second 0, 4. And that leaves me with 7 labels, so these are my rats that I'm going to assign to my first treatment. So this leaves me with 0, 7, 0, 9, 0, 6, 0, 8, 12, 0, 4, and 11. So these will be given the tea extract treatment, and the rest of the rats will be given the placebo. For the last part of the problem, unknown to the researchers, the 5 rats labeled 01 to 05 have a genetic defect that favors cataracts. If we simply put rats 01 to 07 in the T group, the experiment would be biased against T because those rats are more likely to develop cataracts no matter what. So I carried out a random assignment of 7 rats to the T group 20 times and kept track of how many of rats 01 to 05 were in the T group each time. For part C, does this histogram show that random selection reduces bias, and explain why? Well, I would say that it does show that it reduces bias, because in most of the random assignments, 2 or 3 rats were assigned to the T group. And to have no bias, we want on average for half of the rats with the defect to be assigned to each group. So we would want a mean here of 2.5, and in fact the mean for this histogram is 2.75, so it's a little bit higher but pretty close to 2.5, so it seems like that is good for reducing bias.